Okay, that's two blocks shown on the diagram are resting on a horizontal surface when a force P is applied to block B. Blocks A and B have mass 20 and 35 respectively. Find the coefficient of friction between the horizontal surface. The coefficient of friction between the two blocks is 0.35, while the coefficient between the horizontal surface and block B is 0.3. Okay, no bother. So here's what we're going to do. I'm going to grab this here, make a larger diagram of this, like so. Now, here's what we're going to do. Just a lot larger. Okay, so block B is going down, has a weight of 35 G, and we call this reaction force R2 acting upwards. Block A has a weight of 20 G, so we use different colours, 20 G, and it has a reaction force of R1 going upwards. Now, if R1 is going upwards, that means B is feeling R1 going downwards on it. Okay? Alrighty. Now, the deal is here is that A and B travel together. Okay? So, if you imagine that they're both moving to the right, they're both moving together, which means that A is firmly stuck onto B. Alright? Now, the only thing that will keep A in place is friction. So this means there's a friction force that obviously is the only reason why A is sticking to B, and friction is the only reason it's going forward. Okay? So if you imagine A here, okay, it's going up at R, it has a support at R1, it's going down to 20 G. Its friction force, which is the only force holding it in play, and which is the only force that can make it move. They move with a common acceleration A, because it says that before A slips, so A doesn't slip backwards. If B moves too fast, A will slip backwards. Okay, so that's what can happen there. But at this point in time, the friction is holding it in position, and A will not. It will stay exactly where it is, traveling at the same acceleration as B. All right. So this is acceleration A, and it's caused by friction, and friction is mu r, which is 0.35 times 20, and 0.35 times 20 is 7 newtons. So friction is 7 newtons to the right. Okay, and that's what's keeping that in play. Now the deal is with B. Now B is the more complicated one. So the deal is with B is B is being pulled across with a force P, and it's obviously getting restricted by its friction with the ground. So this is friction due to the ground. But believe it or not, because it's holding A in place, there's also a frictional force caused by A, which is the 7 newtons, and that's going to be in the opposite direction because it's slowing B down. Okay. Now once again, B has R2 going upwards. Okay, and it also has R1. Now R1 is balanced with 20 G. Alright, so when I say R1 acting downwards on it because of A, it's actually carrying all 20 G, to be honest. Okay. Now, and don't forget your 35 G downwards. Now we're going to do statics. Okay, now statics means because B is not sinking into the ground, so B is balanced, it's not sinking into the ground. So this means forces up equals forces down. This means that R2 acting upwards must equal 20 G acting downwards and the 35 G acting downwards. Essentially R2 is supporting the weight of both particles, and you could jump to that conclusion right away because they're both flat and both going downwards, so that would mean it's supporting both their weight. Now this means that oh, I'm just after realising something about my 7 newtons. 7 newtons. It was 0.35 times 20 G. Not so. That's actually It's actually 7g newtons, not 7 newtons. So that's 7g, and that's also 7g. My bad. It's grand when you suss out why isn't this the same as the last one, you can find these mistakes. Now it was 0.35. Now the new friction is 0.3. So the friction with the ground is mu r, is mu r2, and mu r2 is what's it, 0.3 times 55g. So 55 multiplied by 0.3 is 16.5 newtons. Okay, so that's 16.5 g newtons. Okay. Okay. Now we're going to look at B, which is here, and we're going to determine its acceleration. Okay. So force, and it's going to the right. It's going to equal P moving to the right, and it's going to be minus the two frictions. They're the only things moving it to the left. So the force is going to be ma, which is 35a, because we're talking specifically about particle B. Now it's going to be minus 0.35 times 20, which is your 7g newtons, and then it's also going to be your 16.5 g newtons acting to the left as well. So both is acting to the left and P acting to the right. Now we haven't got an A value just yet. Okay, so we have to figure out what the A value is. So if we go to particle A, and particle A is moving across with 7g newtons, okay? So what we can say is force, so ma, which is 20a, and that's moving directly to the right, and the only thing causing A to move to the right is that 7g right there. So A equals 7 over 20g. 7 over 20g, okay? So now we can say that's 35 times 7 over 20g. Now I'm going to move to 7g over the other side as well, and the 16.5, and that all equals P. Okay, I'm going to put all that into the calculator. 35 times 0.35 plus 7 plus 16.5 g, and that equals 35.75 g, and when I multiply that by 9.8, we're going to get 350.35 newtons, and that will equal your P value right there. Alright guys, thanks very much, and thanks for listening.